Hi, welcome to Earth Science Online. Today we're going to be talking about mountains. But before we begin our discussion on mountains, let's do our warm-up questions. So our warm-up questions are from our previous lesson on volcanoes. So these critical thinking questions include, what is a volcanic crater and how does it differ from a caldera? What is pyroclastic flow? What are the characteristics of a pyroclastic flow that makes them so dangerous? And where are Earth's major volcanic belts located? So I'll give you a few minutes to look over your answers, make sure there are no changes that you want to make, and then we'll look at the answers together. All right, let's go ahead and look at those answers. So what is a volcanic crater and how does it differ from a caldera? A crater is a bowl-shaped depression less than 1 kilometer in diameter, which forms around the central vent at a summit of a volcano. A caldera is a larger crater. It can be up to 50 kilometers in diameter. Calderas, typically lakes are formed. Calderas are where the walls of a volcano have collapsed onto the magma chamber. So any of those answers would have been acceptable. What is pyroclastic flow? What are the characteristics of pyroclastic flow that make them so dangerous? Pyroclastic flows are clouds made of tephra that travel down the flanks of volcanoes. They move at very high speeds, it's very hot, and they contain poisonous gases. Where are Earth's major volcanic belts located? The Earth has 2 major belts. We talked about these in our last lesson. They're associated with convergent plate boundaries. The Ring of Fire is located in the Pacific Ocean, and the Mediterranean belt is located in the Mediterranean Sea. It includes Mount Etna and Mount Vesuvius, 2 composite volcanoes in Italy. Okay, so let's talk about mountain building. So we talked about volcanoes and how volcanoes are one type of mountain, but there are other types as well. So I'm just going to go through the different types of mountains and how they're formed. So stress, we've talked about stress before. It's a force acting on a rock. It has the same units of as pressure in terms of the force, same units of force, pressure, but it also has a direction. So unlike pressure, which is just kind of coming from everywhere, you have a specific direction for stress. Tension pulls rocks apart, compression pushes together, shearing, rocks slide past each other, and eventually twist apart. So that is going to be, those are your types of stress, and we've talked about those. Stress on the rocks causes the rock to strain. Strain is, of course, the response to the stress. Rocks only strain when placed under stress. Any rock can be strained. It can be elastic, brittle, or ductile, and we talked about ductile deformation being permanent. Stress can happen without strain, but strain cannot happen without stress. So, how does this go into mountain building? Well, stress and types of faults have very much to do with mountain building. So faults are breaks in rocks that make up the Earth's crust, along which rocks move. A break in the Earth's crust that has no movement is called a joint. Parts of the fault. So there are 2 parts of the fault. The hanging wall is that overlying block of a fault having an inclined fault plane, and the footwall is the underlying block of fault having an inclined fault plane. So here you see your 2 parts of your fault. So here's going to be like your hanging wall, and here's going to be your footwall. And your types of faults we've talked about before are normal, reverse, and strike slip. Strike slip is also called lateral, but you mostly hear strike slip. So normal fault occurs when the hanging wall moves downward relative to the footwall. So you have that tension, and it's going to be going in opposite directions, and so finally that hanging wall just drops while that footwall just stays in place. And here's some examples. You can see kind of that hanging wall there. So like here in Utah, Canyonland National Park, you see this hanging, oops, sorry about that. You see this hanging wall. It's going to be located along here. And you see that the normal wall is up here, or the foot wall, excuse me, is up here. Here's another example in Death Valley, California. You can take a look and see your hanging wall and your foot wall. Now, reverse faults are when the hanging wall moves upward. Again, we talked about this before. It is the result of compression stress. So the strain is going to be this upward motion of the hanging wall in response to the compression stress. And here are some examples. You can see the lines here. You can see in the shale layers of this reverse fault, you can see these layers are not, they don't go together anymore, but they are congruent. So you can see that these go upward, these go downward. Same here, congruent, but not together. Here, here. So that's a good example of those compression faults. Strike slip. So rocks on either side of the fault slide past each other. Sliding force is called shearing. Forces bend and twist. No foot or hanging walls. Instead, you just have two walls that are moving in opposite direction. Here, this in Nevada is a good example. You can see how this was once together, but now they are separated because of that movement. All right, so going back to mountain building, what does this all have to do with mountain building? Well, the types of faults and stress are going to determine what type of mountain is built. So folding occurs in rock layers when rock layers bend instead of break. So you can have an upward fold in a rock layer or a downward fold in a rock layer. So what's going to happen is instead of your ductile deformation, when you have tension or compression, you're just going to get a bend in the rock. And so that's going to cause this kind of folding motion. And so that's going to result in driving up that land and causing mountain formation. And you can see here, this is a good example of that. So you can see the way the bedding goes in this rock, and you can tell that it was once going in a different direction, but because it's been pushed, it's now not going the same. They're not perpendicular. They're going in opposite directions. They're going different directions. So instead of breaking, it just bent and folded, and so now you have a mountain being built. So here are some other examples. You can see where that bend happened from that stress, causing a shift and a change. See here this sort of upward movement, folded upward. Here you can actually see a downward fold. So I push this part a little bit further upward while this kind of cratered down. So in mountain building, the rocks are going to bend rather than breaking. So you don't get to that point of ductile deformation. So instead of an earthquake happening, a mountain happens. So compression forms anticlines, synclines, reverse faults, thrust faults, folded mountains, volcanoes, island arcs, and trenches. Tension, normal faults, fault block mountains, rift valleys, mid-ocean ridges, and volcanoes, and shearing, strike slip faults only. So mountain building actually it refers to the mountain formation. These geological processes that underlie the formation of mountains. Processes are associated with large-scale movements of the Earth's crust. And your three main types are going to be volcanic, folded, and fault block. So we've already talked about folding and mountain formation and movement. Let's talk about volcanic mountains. So volcanic mountains occur where magma reaches the Earth's surface and becomes lava. We've talked about our three types of volcanic mountains in our last lesson: cinder cone, shield, and composite. So volcanoes are very common along subduction zones and areas. So you can have two oceanic plate boundaries that meet and one descends on the other. That forms a subduction zone. So one is going downward, one's upward. As part of that subducted plate, that moving downward plate melt, magma is forced upward to form a series of volcanic peaks, and these are called island arc complexes. So like that Pacific Ring of Fire, for example. An oceanic plate and a continental plate also can converge to produce major mountain belts. So instead of two oceanic plates, we have an oceanic plate and a continental plate. So in addition to this uplift, compressive forces, so this force squeezing them together, causes the crust to fold and thicken, and this creates higher and higher mountains. So we don't actually reach that point of breakage. Instead, we just get that folding, and it's just going to keep going up, up, up. Volcanoes also occur at hot spots. We've talked about this before. Volcanic mountains at hot spots are not part of mountain ranges. They're solitary. Hot spots are weak areas in the Earth's crust where magma can make its way to Earth's surface. We talked about this before. So that's going to be your lone volcano. It's going to typically be over a hot spot. Here are some examples of volcanic mountains: Mount St. Helens, Mount Pinatubo, and Mount Mauna Loa. I showed you Mount Mauna Loa earlier, and Mount St. Helens. So those are your volcanic mountains. Now let's talk about folded mountains. So we talked a little bit about folding. All mountains are going to come out of movement of material of Earth's crust and under Earth's crust. When plates collide or undergo subduction, when one descends upon the other, the plates buckle and fold, and that's how mountains are formed, because you've got this folding. But notice there's no magma involved. You just have this movement, and what is happening is, instead of ductile deformation, you're not having that breakage. You're just going to have the land in the area bend and bend and bend until finally you just get this mountain formation. Folded mountains are the most common type. The world's largest mountain ranges are folded mountains. These ranges were folded over millions of years. Examples are the Himalayan mountains, the Andes mountains, the Alps, that would be the Swiss and the Italian, the Rockies in North America, the Urals in Russia. So lots of mountains formed in this way. Now let's go to fault block mountains. Okay, so fault blocks. So what is it? So when a fault block is raised or tilted, fault block mountains can result. So we see this, earlier we were looking at fault blocks, and we're looking at the Horst and the Graben. The Graben part of, you have these lines. You have this heat and upward swelling, and what happens is you have this upward swelling and you have tension forces pulling this apart. So what's happening is this area is being pulled apart from this area here along this line. And so as a result, gravity is going to make the graben just fall. And so you're going to have these two horses that are still up, but then this depression here, this graben depression. And so that's going to be how fault block mountains are created. So literally just a section of Earth's crust just drops. The Sierra Nevada mountains on our continent are a good example. Also the Harz Mountains in Germany. So you can see here, you can see these peaks that are coming up. You see them over here and over here. Then you can see there's going to be this drop off. We can't even see the land anymore. But if we were to go over to the edge of this and look downward, we'd be able to see the land, and that would be that fault block. So that's how those were created. Okay, so let's look at our critical thinking question. So our critical thinking question is, what are 3 types of mountains and how and where are they formed? So I'm going to give you a few minutes to answer because this is our final video, and then I'll go over the answers with you. So just take a minute and look back through your notes. Let's go ahead and look at the answer to that question. So 3 types of mountains include volcanic, folded, and fault block. Volcanic mountains form when magma reaches Earth's crust. 2 oceanic plate boundaries can meet and one can descend on the other, forming a subduction zone. As parts of the subducted plate melt, magma is forced upward to form a series of volcanic peaks called island arc complexes. An oceanic plate and a continental plate can also converge to produce major mountain belts. The descending oceanic plate forces the edge of the continental plate upward, and in addition to this uplift, compressive forces cause the crust to fold and thicken, creating higher and higher mountains. Folded mountains occur when plates collide or undergo subduction. The plates fold and buckle, forming mountains. And when a fault block is raised or tilted, fault block mountains can result. So there you have it. So I hope that I have been able to help you understand mountains, and I appreciate you viewing this video, and I hope you have a wonderful summer. Thank you so much.